Okay, so I've got a horizontal platform, weighs 300 pounds, radius of gyration of 8 feet. This thing is rotating around the z-axis through the center, begins at rest when a man of 150 pounds starts to run at the edge there, 10 feet away. If he's running at 4 feet per second relative to the platform, what's the angular velocity of the platform? Now, about point z, angular momentum be conserved because if I take the man and the platform together, then any impulses are internal to the system, except for what's going on at the pin joint. But again, I'm summing the moments or the momentums, the angular momentums about that point. So we have conservation of momentum. So again, the sum of the I omega 1s have to equal the sum of the I omega 2s. And everything begins at rest, so initially this thing all goes to 0, right? So we get 0, and then we have the man, which we're just going to assume is a point, so it's going to be RMV, where R is 10. His mass is 150 divided by 32.2, and his v we'll get to in just a second. It's not necessarily 4. Remember, it's a relative velocity, so we'll get to that in just a second. That's going to equal I omega of the platform, where I is going to be the mass divided by 32.2 times radius of gyration 8 squared times omega. And I have a negative on there because if the man goes one way, he's going to be pushing the platform in the opposite direction, right? So he's going to be rotating, going around one way, platform will be going around the other way. So let's now go and let's talk about how we can relate these velocities, right? Because essentially the velocity A, which I'll call the man, so I'll call this A up here too, equals the velocity of B plus the velocity of A relative to B. And again, B is, I'm going to say, the platform right under his feet, right? So the velocity of the platform under his feet is whatever omega is times 10 feet away, right? And again, that's going to be moving in the negative direction as we have it defined here. And again, his velocity, the velocity of A relative to B, his velocity relative to the platform is, of course, 4. So this is how we relate his velocity and the angular velocity of the platform through that relative motion equation there. Okay. So using these two equations, now let's go ahead and do it. So 10 times 150 over 32.2, that is 46.6. VA then is going to be 4 minus 10 omega, and then minus 596 omega. That's the 300 divided by 32.2 times 8 squared, and that's going to equal 0. So now I can just, again, that's just solving or plugging in what I know about the velocity of A relative to the omega. I can plug that in, find that my omega then like so.